everyone, welcome to the lecture 35 of course Climate Change and Extreme Events. In the previous lecture, we have primarily summarized all the analytical statistical methods which we have covered so far in this particular course. We have started with some sort of exploratory analysis and then descriptive analysis, then sort of time series analysis, then how do we graphically represent the data set using box plot or bar plot or time series data set analysis plot. Then we have also discussed about some sort of frequency analysis tools which can be using regular distribution functions, which can be normal, log normal, or gamma distributions like that. And there is some sort of distributions which are specific to extreme values. So, extreme values distribution can be Gumbel, Fritchett, Weibull, generalized extreme value distribution G, V like that, log Pearson 3 like that. So, these can be used to do some sort of extreme value analysis. Why it is important? Because when you have extreme value distribution and extreme value analysis, we can tell you about what is the magnitude of the extreme value plus their return period. That is helpful for impact analysis and for analyzing the changing behavior of your extreme events in a particular locations. It is also helpful for, let us say, planning of infrastructure, whether a particular dam or some sort of extreme events protection structures are which we have built there are in a very good situations. If it is old, then whether we need some sort of design modifications like that, or if it is we are planning some sort of new structure there, what sort of new things we should take into account when we are making those structures. So, those ideas will come from when we have analyzed the historical data set, and then we would be able to tell about how do we plan the structure, which area is more prone, therefore this area is required that kind of mitigation or structural or non-structural approaches like that. Then we have further talked about how do we do some sort of data cleaning, how do we do some sort of graphical representation, how we do some sort of overall multivariate analysis. So, these sort of things which we have already discussed in the last lecture 34. In this lecture, we will integrate whatever we have learned from in the last lecture as well as the previous few lectures, and we will club it together, and we will try to find out, let us say, if you try to understand a case study, let us say you take example of your any region where you are interested in, any given region where you are interested in, what is the pattern of, let us say, floods, what is the pattern of heat waves, what is the pattern of droughts, anything if you want to explore in a certain region, how do we do that? That is basically an integrated case study project you can do, you can implement on your own, and then you can tell about how do you what would be the results when you are analyzing the historical patterns like that. So, the learning objective of this particular lecture is we have to apply whatever we have learned, the statistical, analytical and techniques to the real world climate extremes. Then we will also demonstrate, I will demonstrate the integrated use of the remote sensing, GIS and machine learning tools. How do we integrate them? We will also discuss about interpret the results and communicate finding clearly. We will also discuss about how do we strengthen the problem solving and analytical thinking skills when we are clubbing it together, multiple approaches together, and then we will finding out what is the results out of it. So, how do we select a case study? We will not be able, so for example, it is not like we have to do some sort of random. So, it has to be some sort of basis why you are interested in doing a case study in a one particular region. It might possible that you have observed a significant rise of the climate extreme events in a certain region, that is one possibility, and then you try to find out what other people have been reported so far, and based on your observations, based on your colleagues or other researchers observations, you build a story. Okay, this area has more frequencies of extreme events in last 10 years. Therefore, we have to go with this particular area, and we have to basically implement some sort of analytical or mathematical or statistical model which can tell you about how the extreme events has been evolved through the time. Whether we are thinking, okay, what is the observations data set is suggesting, what our mathematical model or statistical analysis is suggesting, whether it is basically coming increased from the last 10 years or last 15 years, last 20 years, something like that. So, that is basically the relevance of study. So, what is the first point? We have to basically define the objectives of the study: climate impact, disaster response, vulnerability assessment, what kind of the study you are looking at. The second is list of potential events. If you are, let us say, talking about 2020 South Asia heat wave, or 2023 cyclone, or 2021 floods in Europe, or there are multiple other events in Indian region as well. So, how these potential events or potential drivers are have influenced the event of that particular location where you have selected the case study. Then third is, how do we check? So, suppose you start checking the documentation, you start looking at the scientific reports, you start looking at the new articles, you start looking at the government publications and all, what other people have been reported in that particular region. That is your making your story more robust, more strong, foundation should be more strong. Then you start digging, start with your analysis like that. Then you start assessing the data availability. What is the total amount of data you have available? The data is available, right? It could be from, let us say, observational network, ground observational network. It could be from your remote sensing data, satellite data set. It could be from your reanalysis data set. It could be from multiple source of the data set. It could be your climate data, it could be hydrological data set, it could be socioeconomic data set. So, that is called assessment of data availability of different types of data in that particular region. Then we basically move to evaluate the relevance of the problem, whether if you do some sort of analysis in that region, why it is important. So, let us say it might possible that one particular district, if you are interested in, is very famous for producing wheat or rice, or there are so many people who are living in that particular districts are coming into that lower strata of socioeconomic levels. So, that is why that is kind of the regional interest. So, you need to know about what is the vulnerabilities of those people or the crop yield, or let us say there are so many factories are installed in that particular region, how those factories production are likely to be influenced by a flood event or drought event, or let us say heat wave event. If you recall, there was a event in Hyderabad and Bangalore, which was so massive flooding, urban flooding, that for that particular day people were stuck in the public congestion, traffic congestion there. So, that is basically has significantly impacted the productivity of that city. The socioeconomic activities or the office going people have been stuck in the traffic jam, and that has basically influenced the overall socioeconomic conditions. So, therefore, you would be able to, let us say, find out that relevance of that problem, and then you can start thinking about how do we use that information for the climate change indicators, how do we do some sort of policy implications when you are dealing with that kind of particular problem. So, once you have analyzed all these 5 points of one particular region, you have to fix that area. Okay, now this is the area where I have to work on. I have to start digging more details on the data and start analyzing with our available set of the data sets like that. Now, the next step is data collection and pre-processing, because we have already set up the data or the area. It is the area which we are interested in. You have also looked at what kind of the source of the data sets which are available. Now, the next step is we have to start extracting the data from that particular region. So, that is called defining the data needs. We have to define what kind of the data is required if you are planning to do some sort of univariate analysis, whether floods, for flood extremes do you have discharge data is available, or if you are talking about rainfall extremes, do you have rainfall informations are available. Like those information, you have to basically check what kind of the data sets which are available and what is their nature. Then you start collecting the data from different sources. It could be IMD, it could be NOAA, it could be national sources, it could be international sources, global repositories, like that. Then once you have identified the source and when we have started collecting the data, you have to basically handle the missing data. You have to address what is the missing or incomplete data using different types of techniques, and then you start filling those data set missing gaps so that your data set should be smooth and it should convey the overall pattern of the seasonality or annual or daily variability, like that. Then you have to start doing some sort of performance of temporal aggregations, convert data into monthly seasonal average to look at monthly or seasonal behavior. Then you start doing some sort of spatial aggregation, where you have to talk about how the spatial behavior of the data for that particular month or for period, like that. Then you can also start thinking about, we can also do some sort of error removal techniques, bias corrections, and then you remove the errors which are there in the observational model data with the observational data set. Once it is done, let us say you have multiple variables, it is also possible that these variables has different sets of units. Therefore, you cannot compare all these variables together, because some variables may ranging from, let us say 0.1, 0.2 to 1, like that, or there is another variable which are ranging from, let us say 10, 20, 100, 200, like that. So, you cannot compare the second variable with the first variable very efficiently, because the range of the value minimum and maximum will vary, is highly very different from the first variable, and there in that case you do some sort of normalizations, that basically you are trying to rescale the data in the similar scale, so that it will represent the behavior of the variable more accurately. Suppose you have soil moisture data which has a very different unit, you have rainfall data, you have flood data, you have some sort of NDVI data. So, all have the very different unit. How do you compare this data set? You have to rescale, you have to normalize the data into 0 and 1, so that you can compare the data in one particular scale, and then you can efficiently compare. So, if you have peak in the flood, you have also peak in the rainfall, and therefore, you have also peak in the soil moisture, like that. So, this is the way you basically you can tell about how the 2 or 3 or 4 these variables are related with each other. How do we do this kind of analysis? You can use Python, you can use R, you can use multiple spatial data set programs, for example QGIS, ArcGIS and Google Earth Engine for this analysis, and that can tell you about how we can do that data collection and pre-processing. Then there is another step, is basically you start dealing with that data, you have already done that, then now you can start doing the trend analysis. So, you can start with anomaly detection, identifying the unusual pattern in the climate data like temperature, precipitation, stream flow or other relevant climate hydrological variables. Then you can talk about descriptive statistics, we calculate the central tendency and variability of the data set. You start visualizing the data, how the graphical methods, for example box plot, time series plots, trends and lines are basically giving you the visual information of the data variability or data analysis. Then you start examining the modeling changes over time, for example trend analysis. You are started dealing with some sort of models which can be machine learning based model or statistical model, or let us say forecasting model, ARIMA model or simple linear regression model. So, this kind of the trend analysis or some sort of trend analysis examination which can be done to basically model the changes over the time, and that can be used to forecast your values for few more steps in the future. Or let us say you wanted to know about scenario based analysis, that can be done by trend analysis, let us say. Then there is a result interpretation, you have to look at the finding of your data, you have to understand the implication of the data finding, and then you can correlate and you can tell about which variable has a bigger role, which variable has a slightly lower role, which variable has crossing a certain threshold more frequently, which variable has significantly affecting the occurrences of climate extremes in that particular regions like that. So, those kind of the interpretation can be done when we have done all of these analysis one by one. What are the tools we can use? Of course, the programming environment like Python and R. Then you can also use Excel, but you can use Excel for this kind of analysis as well. Then there is a special tool, for example, GIS, ArcGIS tools that can tell you about graphical representation of the data set and can tell how graphically you can represent the variability across. Then there is another analysis we can also plan, which is probability and return period. Why it is important? Let us say you are interested in probabilities, you are interested in extreme value magnitude, you are interested in how frequent a particular climate extremes are occurring in a one particular location like that. So, you have to identify the climate extreme variables, select variables with the extreme values, then you start fitting the variable probability distribution functions. It either could be GV, Gumbel, Pritchett, Weibull like that, and then you start estimating the return periods from the fitted distribution, which can be calculating the return period using the CDF function. Once it is done, then you would be able to calculate the return period estimates from that fitted probability distribution function. Once it is done, then you start looking at visualizing the results. You have to create the PDF plot, you have to create the CDF or return level plots, and then you can compare how two regional informations are different, how two temporal informations are different. Let us say you break the data into two parts, and then you calculate let us say how the 100-year return period magnitude has been increased or decreased, or let us say you are comparing two places, place A 100-year magnitude are more than place B 100-year magnitude, like that. These kind of analysis you can do, and then you can tell about what is the overall vulnerability of the extreme events in that particular regions like that. Then you can also do some sort of analytical tools analysis, which is employing the Python, R, or several different libraries are there. I will tell you few of them. For example, you can use extreme library in the R, and that can tell you about this extreme value distribution analysis. There is another library called Copula in the Python and R as well, where you can do some sort of multivariate analysis, and you can look at how you can correlate the behavior using the Copula method. There is another library called T series, where you basically can look at time series analysis using the data set you have in the R like that. So, what is the advantage of these libraries, functions like that? It is robust, it has been already developed, checked multiple times. So, you can use it, and there are inbuilt functions to plot the figures. So, customized figure you can also do, and that will tell you about overall the variability in the data set more efficiently. Then there is a, let us say if you are planning to do some sort of multivariate and Copula based analysis. You can select the variables, select two or more dependent variables for compound hazards. Then you start pre-processing the data set, fit univariate distribution and transform data into uniform margins like that. Then you start fitting the Copula. Once you have marginal distributions is done, then you basically can start fitting the Copula to the model. Based on different Copula model, you have to select which Copula model is basically gives you the better results. Similarly, in the when you are talking about marginal distribution fit, you have to also select which kind of the marginal distribution function is appropriate for fitting in a particular data set. How do we do that? Basically, you can do some sort of QQ plot, you can graphically visualize the results. You can also look at calculate the matrices, for example, correlations between your quantile plot, or what is the total AIC value or something like that. You can use those information to basically fit the univariate or marginal distribution and then fix that marginal distributions like that. Once it is done, then you can start looking at the cupula model. Cupula model, you can take matrices like AIC, BIC criteria to fit a particular cupula, and that cupula, if you have figure it out, okay, this is the best cupula, you can use that cupula model to estimate the probability, joint probability estimate using the joint CDF functions, and to estimate the joint probability in written periods like that. So, this is you can do that using the joint probability estimations, and once it is done, then you can visualize the structure, use various plots to visualize the dependence structures using these types of cupula data set. So, that is important when we are using the multivariate analysis. It is also very important when you are selecting the variables, it has some sort of physical connections. You have already prior checked the correlations and all. You have also checked the consistency of the data set or whether we need to have a data set for same time period, or whether we should have a data set for a lagged version data, of some sort of things which you can learn from some sort of literature reviews and all. So, that is basically if you are planning to do multivariate and cupula analysis. Let us say if you are planning to do some sort of machine learning based forecasting, you have to identify the objective, of course, where you have to classify your some sort of goals. You have to prepare the data set. There is a target variable, there is an input variable. Input variable can be many, that can be climatic variable, that can be hydrological variable, that can be land use variable, that can be geological variable, that can be socio-economic data set and all. You have to prepare the data set, and then you can use the data as an input variable to the modeling of the target variable, and you can calculate what is the behavior. Once it is done, then you can start choosing the model, which model is performing better, whether random forest, whether LSTM, whether multiple different types of machine learning, deep learning models are better, and once it is done, then you can start dealing with training the model. So, you have to split the data into two parts, 80 and 20% like that, and 80% data set you use to train the model to find out the parameters of the model efficiently, and then rest of the 20% you use for testing the model, whether your test of model is correct or not, whether when you are testing 20% with your data set, how well your model is performing. So, that is called training and testing of the model, or evaluation of the model using some sort of different parameters, accuracy, precision and other metrics. When it is done, okay, you are sure that, so k-fold validation, for example, leave one out validation algorithms like that. So, these are the ways you can basically correlate or basically look at your evaluate your model. Once it is done, then you can start tune the model further, optimize the model. Let us say if the evaluation models suggest that you can further improve that accuracy, then you can tune the model using the optimization approaches, Bayesian optimization or grid search or like that, and then you can basically use that fixed model, which is now you think that now it is the correct one, is the best one. You can use that model to forecast events using different scenarios, climate extremes conditions or future climate conditions like that. So, that is what we can do for the ML and DL approaches. Then there is another is basically visualization and mapping. So, use some sort of tools, for example, visualization. Basically, when you do all these analysis, the visualization is the very critical step. If you are not able to properly visualize your results will not be able to convey to the to other persons or readers very efficiently. Therefore, visualization is a very important step. We have to visualize the map so that it will tell you about the particular objective. We have to perform the analysis. We have to tell about what kind of the objectives we have done or analysis we have done. Create maps, we have to develop thematic maps using the satellite and socioeconomic data set. Collect data set, prepare spatial data and various data sources, and display patterns. We have to basically visualize what kind of the events and extent vulnerabilities are there. So, therefore, you have to display the patterns, we have to collect the data, create maps, perform analysis, visualize map and use tools for these kind of the analysis like that. Then there is another thing is basically interpretation and discussion. This is very important step when you have already drawn multiple figures. That is the next step is how do we correlate your results with your other findings, other people's findings, or if you have socioeconomic data, how you are interpreting your results, that these results are likely suggesting that it is going to affect the socioeconomic conditions of one particular region. You should have some sort of proof to give it. So, you have measure results, the key insights from the climate data or analysis like that. You have already identified the patterns and anomalies in the data set, and you have already checked the reliability of results, performance and data quality. You have to link to the data, whatever model data you observed, with the climate change, comparison of the current events with the historical climate data, and then you can comment on how the climate change has been influenced the behavior of a particular variable which you have done in the modeling. Then there is the implications. Suppose you have done some sort of flooding analysis, and then you can tell about what is the overall implications on agriculture, what is the overall implications on let us say urban area, what is the overall implications on riverine flooding like that, what is the overall implications of a drought even in a certain region where we have growing lots of wheat productions. So, these kind of the things which we can do that, and we can discuss, and we have to discuss about what kind of the policy relevance and adaptation strategies which we have to adopt to slightly mitigate the negative consequences of these climate extremes. So, this is how basically we have to find out, we have to do some sort of discussion in very critical way, so that people can learn about your analysis, people can think about correlate with your analysis with ongoing historical climate change or current climate change conditions, and they can also learn about what sort of the solutions you are providing that can be helpful for improving the situation in that particular regions like that. Then you have to also identify the limitations. It is possible that all the studies have limitations. So, you have to reflect those limitations that will pave a way for future studies, because if you do not reveal your limitations, people will not be able to understand which limitations or further analysis is required to fulfill the goal which you have set up. So, this is basically a reflection of the lesson learned. Integrated approach are crucial. You have to talk about local context matters, you have to talk about data integration is key, then you have to suggest some sort of future improvements, high resolution data set, for example, ensemble modeling, stakeholder involvement like that. That will tell you about overall the reflection and the limitation of your analysis. So, overall, when you are selecting a real world applications to strengthen the methodological understanding, you have to follow a step by step procedure which we have discussed in the class, and then you have to integrate some sort of tools. It could be your analytical tool, it could be your statistical tool, it could be your graphical tools, it could be your some sort of policy interventions or socioeconomic data set. Those kind of integrations are very required. That will tell you about what is the overall gravity of your work, whether whatever you have done in the field of climate extremes is very relevant in that particular region, and people should look at these crucial details. Then there is another important thing is how do we communicate your results, how do we properly write your results or communicate to the people who are interested in to read that particular results, and that is very crucial steps, because if you are not able to communicate properly, it might possible that people will not be able to know that what kind of the problems this particular area is facing right now, or what would be the implications like that. So, that is the communication is a very critical step, and that has to be done by after the analyzing the results which you have done in the discussion section, and based on some sort of secondary or different data set analysis as well. So, this is all about the today's lecture. In the next lecture, we will primarily discuss about overall the course wrap up, whatever we have discussed so far, and probably some sort of discussion on the future research directions. Thank you so much for your listening.